How's it, grade nines? Today we're going on to exponents. So just initially it's going to be revision from your grade 8 work. Okay, so if you remember, you've got something like this where you've got your factor form 2 times 2 times 2 times 2 times 2. And what we can do is we can write it in exponential form. We just count how many 2's we have. 1, 2, 3, 4, 5. So basically we say it's 2 to the power of 5, okay? And this 2 to the 5 means this. You're going to take 2 multiplied by itself 5 times, okay? All right, just some definitions here. Just remember, whatever's in front of an x is called the coefficient, okay? Then this whole thing here, all right, this is the base, this is the exponent. The whole thing is called a power, all right? So when we talk about an exponent, we're talking about the number at the top. Talking about a base, it's whatever's over here, and then the entire thing there is called the power. Okay, just remember some of your laws here. I'd like you to highlight these for me, please. So your law 1 says that if your bases are the same and you're multiplying, you add the exponents. Okay, so you're going to be using this quite a bit. So let's just have a look at some examples over here. You've got 3 to the 2 times 3 to the 4. Now our bases are the same. We've got 3 and 3, and we're multiplying. So we can apply this law. So how did they get to this bit? They made it one base, and then they just added the exponents. So it's 2 plus 4, which give us 3 to the 6. Okay. For this example here, I'm going to multiply the coefficients first. So we've got 3 times 3 gives us 9. Okay. Now our bases are the same and we're multiplying, so we add the exponent. So this will be p to the 6 plus 5, which will give us 9p to the 11. Okay, your second law from last year, if you remember, if your bases are the same and you're dividing, you subtract the exponents. So over here, our bases are 7 and 7, and we're dividing. So therefore, we can subtract the exponents. So this would be 7 to the 7 minus 4, which will give us 7 to the 3. For this one over here, we can divide the coefficients. Okay, so 9 divided by 3 is 3. Then bases are the same, and we're dividing, so we subtract these exponents. So this will be 3k 6 minus 2, which will leave us 3 to the k to the power 4 there. Okay. Then your third law. If you've got something to the power of something raised to another power, we multiply the exponents. All right. So if we have a look here, we've got 2 to the 3 raised to another power 4. So this would be 2 to the 3 multiplied by 4, which will give us 2 to the 12. Over here, we've got m to the 6 raised to another power 2. So this was m to the 6 times 2, which will give us m to the 12. Now, grade 9s, these three laws are not given to you. Okay, you need to know them off by heart. The best way to memorize them is just to go through all of your examples and practice with them. Okay, so that's revision from grade 8. This was also from grade 8. So essentially what it is, it's basically just an extension of this law here. Okay, so what we've got here is we've got now 2 variables inside the bracket raised to a power. All we do is we just distribute that power into both of them. Okay, so it'll be a to the m, b to the m. Likewise, if you've got a fraction, okay, we just distribute that m into both of them, and it just becomes a to the m, b over b to the m. Okay, so over here, as you guys can see with the example, I just distribute the 4 into both, so it becomes 3 to the 4, 2 to the 4. Now 3 to the 4 will give us 81, 2 to the 4 will give us 16. Okay, over here, what we need to do is we need to multiply these exponents when we distribute in. So this will actually be x to the 5 multiplied by 3 and y to the 2 multiplied by 3. And that will give us x to the 15, y to the 6. Okay, so just remember when you distribute in like that, you are multiplying. Right, just some definitions. These are important. Anything, grade 9s, to the power of 0 is 1. Okay, this comes up a lot in exams and tests. Just remember anything to the power of 0 is 1. Then 0 to the power of 0 doesn't mean anything to us. All right, so you're not going to get anything like that. Now, if we have a look at this example over here, we've got this whole bracket here to the power of 0. Now, I really don't care what's inside this bracket. We could have a million things inside here. Because it's to the power of 0, automatically it's 1. The whole thing must be 1, okay? If we have a look at this one here, only one of these things is to the power of 0, all right? So it's just this one. Now, just remember, if we've got something to the power of something raised to another power, we multiply those exponents. So I need to multiply the 4 with the 0, multiply the 4 with the 2 for the base y. So what they got over here was 4, because the 4 is not affected by this exponent over here. The exponent is only working on this bracket, and the 4 is not in the bracket. So we get here x to the power of 0 times 4 for that distribution. And then over here we get y to the 2 times 4 for that distribution, okay, which will give us 4 x to the power of 0, y to the power of 8, all right? Now remember, anything to the power of 0 is 1, so this x to the 0 will become 1, and what are we left with? 4y to the 8, 4y to the 8, all right? Then just some examples here. I'm going to do these examples with you on some folio paper. And you can just copy down in your books as we go along. So example 1a. The question is, simplify the following expressions. Okay, so we've got 3x squared y cubed multiplied by minus 4x cubed y 4. All right, so we're multiplying this bracket with this bracket. What I'm going to do is I'm going to do numbers with numbers and then like bases. Okay, so numbers with numbers would mean the 3 with the minus 4, and then like bases would be the x with the x, the y with the y, and we would carry on like that. Okay, so first of all, 3 times minus 4. 3 times minus 4 is minus 12. We've got x squared times x cubed. Now remember from your first law, if bases are the same and we're multiplying, we add those exponents. So this will be x to the 2 plus 3. And you see I'm going through it systematically, grade 9s. I'm just grouping things together. Numbers with numbers, x's with x's, y's with y's, z's with z's, and so on. Okay? The next one, we've got y to the cube times y to the 4. So if bases are the same and we're multiplying, we add those exponents. So y to the 3 plus 4. I must just now simplify these exponents, and we get minus 12 x to the 5 y to the 7, and that is our final answer. Okay, if we look at example B, we've got 12 x squared y cubed over 2x4y. Okay, now with this type of one, what I need to do is I just need to make sure that all of my variables have an exponent. So the x has a 2, the y has a 3, the x has a 4, the y, well, it does have an exponent, it's just invisible. So what it is, there's an invisible 1 there, and I'm just going to fill it in, okay? So what we can do now is we can just divide our numbers with our numbers, and then the bases with the bases, like bases. Okay, so 2 divided by, 12 divided by 2 is 6. Now, before I go into another type of law, I want you guys to do it like this for now. Remember that this x squared means we have 2 x's there. This x to the 4 means we have 4 x's over there. Now you can see that the 2 x's at the top will cancel with 2 x's at the bottom. And what are we left with? We're left with 2 x's at the bottom, okay? So we're left with 2 x's at the bottom, which is x squared, okay? Over here, we've got 3 y's at the top, 1 y at the bottom. So 1 y at the bottom will cancel with 1 y at the top, so we're left with 2 y's at the top, okay? And that is our final answer. Grade 9s, when we get onto negative exponents, I will explain another way of doing this where we apply our law to, okay? For now, I would like you guys just to do it like that. All right. We are now going on to example C. Minus a cubed b to the 4 squared times a to the 0 b squared c cubed. All right. Before I start tackling this, I would just like to go through it and just fill in my invisible exponents. So that one has an exponent, 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 exponent. This one has an invisible one. I just want to put it in there. Okay, so here we go. Now, this is a little bit of a tricky one, but not too bad. First of all, we've got a negative and it is squared. In other words, that means that we have a negative times a negative, okay? Times itself twice. So a negative times a negative is positive. So this thing will come out to be a positive. Just be very careful with that, grade 9s. Okay, so negative squared is positive. So I'm not going to put down any sign because it's just automatically positive. Then, if we've got something to the power of something raised to another power, we multiply those exponents. So it's 3 times 2. Likewise over here, we've got something to the power of something raised to another power, so we multiply the exponents. Okay? Multiplied by that, then something to the power of something raised to another power, we multiply the exponents. Something to the power of something raised to another power, you multiply the exponents, and then likewise for the last one, something to the power of something raised to another power, you multiply the exponents. So what I'm going to do is just simplify these exponents for each one. So we get a to the power of 6, b to the power of 8 multiplied by a to the power of 0, b to the power of 6, c to the power of 3. Okay. Now remember, anything to the power of 0 is 1. So we can now say that this is a to the 6 multiplied by b to the 6, b to the 8 times b to the 6 times c cubed. Okay? Because that is equal to, this whole thing is equal to 1. Right, if bases are the same and we're multiplying, we add the exponents. So there's no other base a. So this just stays a to the 6. If bases are the same and we're multiplying, we add the exponents. So b and b, this becomes b to the 8 plus 6. And then we don't have any c's, so this is just c cubed. I'm just going to simplify this exponent over here. A to the 6, b to the 14, c cubed. And that is your final answer there. All right, last example, grade 9s. All right, I know it looks a little bit hectic, but it's really not that bad. So what I'm going to do first is I'm going to simplify what's inside this bracket, okay? So first of all, we know that 2 can go into 6 3 times, 2 can go into 4 twice. So that minus 6 over 4 simplifies to be minus 3 over 2. Then we've got 7 p's at the top, 4 p's at the bottom. So 4 p's will cancel with 4 at the top, and we're left with p cubed. Then we've got 10 k's at the top, 6 k's at the bottom. So the 6 k's will cancel at the bottom, will cancel with 6 k's at the top, and you're left with 4 k's up at the top. All right, and this was all squared. All right, so we've just simplified. Now what we can do is now we can deal with the squared outside. So what is a minus squared? Remember, minus squared is positive. So we know that this is going to be positive. What is 3 squared? What is 3 times 3? It is 9. If you've got something to the power of something raised to another power, you multiply the exponents. Again, something to the power of something raised to another power, you multiply the exponents. All over. What is 2 squared? 2 times 2 is 4. I'm just going to simplify these exponents here. So that will give us 6k, that will give us 8 all over 4. And that is your final answer there. All right, grade 9s. What I would like you to do for homework is exercise 5.1 for me, please. Thank you.